all champions, I Abhinav Negi welcome you all on BYJU'S exam prep, and today me and Dheeraj sir will be going to discuss the previous year questions of Isro. Now how this session will be helping you? Of course, for those students who will be giving Isro, might be this year, or if you are in just second or third year, might be after 2 years. So you will get an idea that how the Isro exam look like, what is the difficulty level. First thing is that. Okay, so even see, fourth year students are eligible for this notification right now. The ad is open, the form is open. The fourth year students are eligible provided they have to submit their degree before 31st August 2023. Still, if you are second or third year student, of course this will help you to understand the difficulty level of Isro. Now guys, as I have studied the Isro, not only the SOM paper but other subjects also, and same Dheeraj sir for mechanical, what we find that the difficulty level is much lesser. I'm not saying less, it is much lesser than the GATE exam, and it is more, you can say, similar to the state services objective exam and engineering service objective exam. That kind of paper it is. Okay, so of course if you're preparing for that also, it will be helping you. Hi Anwar, how are you? So me and Dheeraj sir will be going to do this. Okay, this is my new email ID, abhinav.negi@byju's.com. You can join me on civil by Abhinav sir, or for Dheeraj sir you can join on mechanical by Dheeraj sir. Now this session I have already taken. Okay, so please see this most important topics. Now this Dheeraj sir will be taking 6 PM today on YouTube. If you are preparing for the GATE exam 2024, then this is the opportunity today 6 PM on the YouTube only. This session, the civil engineering complete syllabus I have already taken. You can see this in the live section. Okay, this also some approximations in civil engineering I have done. These two I am going to take this week, so be ready for that also. And there will be a super duper workshop by me on 16th May, that is Tuesday. Okay, this will be on Tuesday, this will be on app, and this will be app free session. Okay, so you can watch that also. Please do register for this workshop. Now I have already told the pattern. Okay, before just quickly coming to the strength of materials, let me tell you the pattern. So exam pattern will be that there will be a part A of 80 marks, part B of 20 marks. Part A 80 marks, part B 20 marks, total 100 marks. So written exam will be of 100 marks, 80 plus 20. Now 80 again, 75% will be civil engineering. Many students are having a doubt. They have asked me in the comment section also. I have replied them that maths will also be here. Engineering maths will also be there. That is 75% of 80, 60 marks, and 20 marks will be allied. Allied means related to civil engineering. Allied means related to civil engineering. So 80 will be distributed to 60 plus 20. This is section A. Then section B will be 20 marks. That will be reasoning, aptitude, logical reasoning, all these questions. You have to be individually clearing the two sections. Okay. Individual cutoff is also there, that is written in the notification. After this written exam, then there will be 100 marks interview. Some students will be going to the interview. For one seat, approximately 10 to 12 students. Now, the final cutoff, this is not like BARC. BARC, this is just a qualifying exam. All selection will be done on interview. No. Here, written test, some students will be selected for interview. While making the merit, individual cutoff is there. That is written in the notification for part A and part B. For the final selection also, the individual cutoff of written test and interview is there. And 50% weightage of written and 50% interview will be taken. Plus 1 minus 1 by 3. Now if I tell you about these 80 marks, okay, then out of the previous year, now not this 80 marks, because the previous year the pattern was a bit different. Previously, you don't consider these 80 marks here, please, because earlier the pattern was different. You can see that the distribution of subjects, just see the ratio. Okay, no Saksham right now there is no test series, but Sariksha, but engineering services will be quite relatable to that. So this is the ratio. Strength of material, RCC and pre-stress are asked in high weightage. Now guys, soil mechanics also decent weightage, environment less weightage here. Engineering mathematics is again. So you can see that soil, strength of material, RCC, these structure subjects are having a little bit more weightage and soil mechanics. Okay, so today I'll be going to for the SOM, and for mechanical students, all the students for mechanical, you can see that heat transfer for RAC is a quite high weightage. This time the specialized seats are for RAC. So the number of questions are more, then FM plus machinery is also more, power plant is also more. Okay, so this is for mechanical. Now let us go to the question, guys. ISRO previous year question 2020 and 2018 we will be doing today. 2020 and 2018 we will be doing today. Okay, Ambati, kaise ho? Are you waste? Every time in the session you say this, na? So quickly tell me on the comment box, guys, answer. This is the question number 1. ISRO PYQ SOM. PYQ of ISRO SOM. This is for civil and mechanical both. This is for civil and mechanical both. Strength of materials. Tell me on the comment box. Everyone. Come on, yaar. Macha do, bhai. Macha do. Easy questions are there, yaar. I told you the level of the question is is much lesser than the GATE exam. The level of the question is much lesser than the GATE exam. Vinay, please take your calculators also, na. So steel rod, yes, very simple, na. Now you cannot say that Abhinav studies or Dheeraj studies doing very easy questions, guys. Whatever the PYQ are there, that we will be doing, na. We just want to tell you the level of the exam. 30 mm diameter, 3 meter length. The diameter is 30 mm and length is equal to 3 meter. Okay, axial pull of 50 kilonewton is there. Okay, Young's modulus is given. So delta is equal to PL by AE. Force is given, length is given, A is given, E is given, everything is given. Okay, everything is given, force, length, AE. So 1.062 will be the answer. These kind of questions are asked in ISRO, and also the same level is expected in the state service examinations. Okay, now moving to question number 2. The shape of the bending moment diagram over the length of the beam carrying a uniformly increased load is always. What is uniformly increased load? What is uniformly increasing load? Tell me, yaar. Tell me, yaar. Tell me, yaar, what is uniformly? Yes, Vinod. ISRO exam most probably will be offline. ISRO exam most probably will be offline. Tell me. Uniformly increasing means that whatever is the beam not given, na, whatever is the beam I don't know, it is simply supported cantilever I don't know. Uniformly increasing. Increasing uniformly, that means linear. Uniformly increasing but uniform. Otherwise increase can be parabolic also. Increase can be parabolic also. So this is this. Now if loading diagram is of n degree, then SFD diagram will be n plus 1 and BMD diagram will be n plus 2. How we know this? How we know this? Because bending moment slope is shear force. V is shear force. So after differentiation, degree is reduced by 1. X cube differentiation, 3x square. So after differentiation, degree is reduced by 1. So if this is n plus 2, this will be n plus 1. Okay, and shear force differentiation is load intensity. Shear force difference is load intensity. Okay. So this is n plus 1, differentiating, it will be like 1 less. It will be like this. So this is linear. Linear means 1 degree. Y is equal to 3x plus 5. What is degree? 1. So this is 1 degree. So load will be 1 degree, shear force will be 2 degree, and bending moment will be 3 degree. That is cubic. That is cubic. Okay, yes, we will be doing all subjects. Don't worry. Don't worry. Just keep sharing the video. Yeah, come on, hit the like button, guys. Now, have you ever wondered why teachers are saying hit the like button, hit the like button? What we will get here from your like? There is an algorithm of YouTube. There is a coding of YouTube. Of course, YouTube is not disclosing its algorithm and coding, but most predicted by the YouTuber specialist is that if the likes are more, then it will be YouTube will be sharing to the students also. Okay. Now I am again saying, guys, level of PYQ of ISRO is much lesser than the GATE. It is up to ESC objective and SSC exams. Now tell me, Hooke's law is valid up to. Hooke's law is valid up to everyone. Keep sharing, keep sharing. it is up to limit of proportionality. Okay, Hooke's law is sigma is proportional to strain, so sigma is equal to like this. Now this is y-axis stress, this is some constant m, this is x. So Hooke's law is suggesting a linear relationship. Hooke's law is suggesting a linear relationship, and linear is only up to the proportional limit. Hooke's law is this. This is like this, y is equal to some m into x, not sigma square, not epsilon cube. So Hooke's law is suggesting a proportional thing, that is up to the linear limit. But elastic limit is the appropriate option, sir, I think. How? विनीत पूरा एक्सप्लेन कर दिया भाई, मैंने तो पूरा एक्सप्लेन कर दिया. आप भी अपना कमेंट में लिख दो कैसे एक्सप्लेन. इलास्टिक लिमिट तक थोड़ी नहीं लीनियर रहता है भाई. अच्छा, तुम्हें बहुत ज्ञान की चीज बताता हूँ आज. तुम्हें बहुत ज्ञान की चीज बताता हूँ सबको. सुनो, इलास्टिक लिमिट तक थोड़ी नहीं लीनियर रहता है भाई. माय माइंड स्टील का ही देख लो. प्रोपोर्शनल लिमिट, फिर इलास्टिक लिमिट, ऐसा कुछ रहता है. तो दिस इज लीनियर अप टू ओनली दिस इज लीनियर ना, एंड हुक्स लॉ इज लीनियर. दिस इज नॉट लीनियर. Elastic limit must not it not necessary to be linear. Now let me tell you a ज्ञान की चीज today. Let me tell you an important thing today. What you generally do, suppose it is a linear elastic curve. We assume, the word is assumed to be linear up to elastic limit. Now, what we do, then we are talking of resilience or anything, we call it sigma y, epsilon y, and area is half base into sigma y. Now strain can be written as sigma y by E into sigma y. So this area is sigma y square by 2. You do this for resilience or whatever. This is a pure wrong thing. Up to the elastic limit, the stress is not yield stress. Up to elastic limit, the Hooke's law is not valid. You cannot write strain is equal to stress by Young's modulus. But beneath there, it is an assumption that proportional limit, elastic limit, yield stress are very near to each other. So we do this. Otherwise, up to elastic limit, if we are finding the area, this is not sigma y, this will be something else. Hooke's law will not be valid. Epsilon y you can't write as sigma y by E, but that is just an assumption. Okay? Got it? Okay. Now next question. The unit of moment of inertia of an area is? The unit of moment of inertia of an area is, let me check that who can give it faster. Okay, everyone, every commando, every champion, come on. Everyone's answer I want. Great. So guys, I is equal to BD by BD cube by 12 or pi d4 by 64. All these are dimensions की power 4, meter की power 4. Okay, yes. Do this now. 1 Newton, guys, force is equal to mass into acceleration. Force is equal to mass, and this is a SI unit, Newton. This is a SI unit. So this should be also an S. Mass will be SI unit kg. Acceleration will be meter per second square. So 1 Newton is 1 kg into 1 this. Okay, like this. Okay, guys, can you please write down your cities, in which city you are right now? Okay, in which city you are right now? I'm right now in Delhi. I'm basically from Uttarakhand. My hometown is Uttarakhand, but right now I'm in Delhi. Can you all write down? We all are meeting in the Sunday beautiful morning. We'll be devoting our some time for the Isro PYQ of SOM. This is for civil and mechanical both. Right now, these are the PYQs of civil. Okay, but it is equally important for mechanical as well. Telangana, Andhra Pradesh, Telangana, okay. Karnataka. So Karnataka mein Congress has won, huh? Swati, Congress won there with a very good amount of seats, although the vote percentage of BJP is increased. Kadapa. What is Kadapa, yaar? Kadapa is some name of any chief minister or the potential candidate for chief minister. Okay, Kadappa. Kadappa is also that in Bahubali also, na? Someone is Kadappa. I have not seen the movie. Okay, I don't watch movies. अनवर फॉर सिविल हर साल इसरो एग्जाम होता है सिविल के लिए, लेकिन यूजुअली वैकेंसीज फॉर सिविल ना, यूजुअली वैकेंसीज ओनली कमिंग 5, 7, 6 लाइक दिस, बट दिस टाइम दिस इज नॉट नॉर्मल नोटिफिकेशन ऑफ इसरो, दिस इज अंडर अ डिपार्टमेंट कॉल्ड CEPO, सिविल इंजीनियरिंग प्रोग्राम ऑफिस. So of course, as it is in the department of civil, therefore most vacancies of civil are here. One normal notification of ISRO will also be expected to come. Okay, district in Andhra Pradesh. Okay, sorry. Now do this. Slenderness ratio, lambda is asked, and slenderness ratio lambda is L effective by R minimum. L effective they have said as 4 meter. So 4 by R minimum. And what is R minimum? R minimum is radius of gyration. R minimum is radius of gyration. Yes, everyone. Come on. Okay, so what is radius of gyration? Lambda is asked, na? Lambda is asked, so R minimum is required. Now I minimum is equal to A into R minimum ka square. So R is equal to under root I minimum by A. What is the physical meaning of radius of gyration and lambda? Can anybody tell me? We all know this formula. What is physical meaning of lambda? If lambda is more, that column will be long, and long column is more liable for a buckling failure. Long column is more liable for a buckling failure. More chances. Lambda more means buckling failure more. Short column means crushing. Short column will not be buckle like this here. Short column will not be buckle like this. It will be more probably curved, crushed. Long column may buckle. So lambda signifies the failure of an object. Usually for steel, if lambda is more than 88, it is in the range of 100, 120, 140. So site engineer understood that it is a chance of buckling failure. What is the physical meaning of R? If R is more, that suggests that particular shape, here R is only depending on shape, I and A, shape, not material. If R of a particular shape is more, it suggests that it provides more moment of inertia. It provides more moment of inertia. Oh yes, it will be, yes. It provides more moment of inertia for a particular area. See, from 2 meter square area, see, suppose this is the area. Okay, suppose this is the area, this much area. From this much sheet, I can make I section also, I can make circular section also, I can make rectangular also. So from all those sections where R will be more, that means it provides greater moment of inertia for the same area. So R more means more strong. Okay, so what is I here? Diameter na. So I minimum, but on all it is circular, so I will be same. About moment, about central axis, it will pi d 4 by 64, and area is pi d square by 4. So R is equal to pi to pi will be cancelled. R will be d square by 16 under root. So it is d by 4. D diameter is how much? 40 centimeter. This is 10. So this is 4 meter, and this was centimeter na. This is centimeter. This was centimeter na. Pi d 4 by 60. This centimeter. So 10 centimeter means 0.1 meter. So this is meter. So this is 0.1. So this will be 40. Have you got it? Everyone, please let me know. SOM PYQ we are doing, guys, for both civil and mechanical. Okay. Let us go further now. The bulk modulus of elasticity, that is E. I am representing this E. Is twice the bulk modulus of rigidity I am representing as G. Somebody represented with other notations also. I am representing with G. So bulk modulus of elasticity is twice its modulus of rigidity. E is equal to 2G. This is given. This is given. This is given. Okay, Anwar, we'll do that, don't worry. E is equal to 2G. Poisson ratio of the material is, so E is equal to 2G1 plus mu. This is the relationship. Okay, twice its modulus of rigidity. Okay, so E is equal to 2G1 plus mu, but E is itself 2G. E is this. So 1 is equal to 1 plus mu. So mu is equal to 0, na? No option. No option. Okay, sorry, bulk modulus of elasticity. Sorry, we have done this mistake. Okay, so this is bulk modulus. This is bulk modulus here, K. This is bulk modulus. So actually we have done two questions here. So this is K. Okay. So relation between K and G is, see, E is equal to 3K, E Young's modulus is equal to, E is equal to 3K 1 minus 2 mu, correct? Okay, and K and G also some relation is also there, na? Mu is equal to, I guess, what was the relation? I forgot. 3K minus 2G upon 6K plus 2G. This was the relation. Check this. The bulk modulus of elasticity check this. Is this fine? The bulk modulus K is equal to 2G. If this is fine. Okay, I will not remember the formulas na. 3K minus 2G. 2G is K itself. 6K plus K. So mu is equal to 2 by 7. This is B option. This is B option. Please check. Okay. So this is not required. This is not required here. Let us do the next question. Let me check that who can do this fastest. Let me check that which student can do it fastest from which city. Which student can do it fastest from which city? Tell me. Everyone out there. Which city will be giving the fastest answer? Let me check. Keep sharing, guys. 2 planks, each of 50 into 50. This is 50 into 50. Nice question. And one is also 50 into 50. Now they are joined by a glue. Okay. They come closer each other and joined by glue. Favicol. So now they becomes a single assembly. Now they becomes a single assembly. Like this. Now what is, no, they have not asked maximum shear stress. They asked maximum shear stress on the glue. So here the maximum shear stress occurs at the center, na? Here the maximum shear stress occurs at the center, na? The maximum shear stress occurs at the center, na? And this glue will also be at the center. So such that these dimensions are joined in such a way. So tau max is equal to 3 by 2 tau average. Because glue is all itself in the location of maximum shear stress. So 3 by 2 tau average kahan gaya? 1000 by area. Area is 1500. 1500. Oh, very easy question. And the answer will be 0.3 megapascal. Everybody. Got it or not? Give me yes or no on the comment box. नहीं आ रहा तो बंद करें फिर. क्या संडे को यूट्यूब लगा रखा है, बंद करते हैं फिर. नहीं आ रहा समझ तो. अनुभव सिंह. Okay. Anubhav Singh, the name itself is suggesting like someone who clears just in a civil service examination. Na, civil service examination, most names are like this, na? Not these years, but in my time in 2011-12, when I was in IIT, 2013-14, that time the names who cleared the engineering services, let me tell you, you will correlate with this. You will correlate with this. When I was in IT 2013-14, the names of the civil services topper are like Vikram Pratap Singh, Rajwardhan Singh Rathod. I know Rajwardhan Singh Rathod is a silver medalist in Olympic, but still. Anubhav Rathod, Vikram Khandelwal, Jograj Singh. These are the names of civil service aspirants. Girls का तो मेरे को इतना ज़्यादा पता नहीं नाम. अब तो सब गर्ल्स ही टॉपर आ रही हैं. टॉप 5 में 4 स्टूडेंट्स आर गर्ल्स. दैट इज वेरी गुड, वेरी गुड. एंड द नेम्स ऑफ द IIT टॉपर्स, यू विल रिलेट विद दिस. नेम्स ऑफ द IIT टॉपर्स आर नितिन मित्तल, वैभव अग्रवाल, तुषार बंसल. यस और नो, प्लीज टेल मी. दीज आर द नेम्स ना, लाइक मित्तल, बंसल, अग्रवाल, all these, Reddy, all these are toppers of IIT and Singh, and all these are the toppers of the civil service examination. Okay. Now moving further, at a certain point in a structural member, at a certain point in this is question PYQ of SOM. This particular question is in theory of failures. And theory of failure is only for civil engineering. This is mechanical engineers study this complete in machine design. Machine design you study this. But for civil engineers, as per the current syllabus, this is not in the GATE syllabus, it is only in the engineering service syllabus. Okay? Now, theory of failure suggesting, which is not in the GATE syllabus of civil engineering, but in the syllabus of engineering services, the stresses are 80 and 20. What should be the equivalent stress in simple tension? See, there are stress 80 and 20. 80 and 20. Now what they are saying? Equivalent stress. Equivalent stress according to strain theory, maximum principle strain theory. What is the equivalent stress? This sigma equivalent. So equivalent stress means it will produce the same strain as per the strains theory. What will the strain here? What will the strain here? Sigma equivalent by Young's modulus. And what is the strain here for this yellow one? For this yellow one, 80 by Young's modulus minus mu into 20 by Young's modulus. Okay. So E will be cancelled. E will be cancelled. So sigma equivalent is 80 minus mu. Where is mu? 0.25 into 20. So this will be 75. Give me yes or no on the comment box. Give me yes or no on the comment box. Okay. Now 2021 more. Two simply supported beams are made up of same material and are of same cross section. Both beams carry uniformly distributed load of equal intensities. One beam is 2 meter long, another is 4 meter long. The 2 meter beam long shows a central deflection of 1 mm. What is the central deflection of 4 meter? Okay. So one beam is like this. Both are the simply supported beam having this W intensity, and what is the length? Kahan gaya length? 2 meter long, and the other is, this is 2 meter long. Okay. And here the deflection is occurring like and the central deflection is 1 mm. Delta is equal to 1 mm. Okay, now what is happening? Another beam is also of same dimension. Everything is same, but length is doubled. This is also W intensity. This is also W intensity. It is 4 meter long. 4 meter long. Now what is the intensity here? What is the delta there? This delta is question mark. This is asked in the examination. Everyone. Now as you know, the delta is equal to what is the formula? 5 by 384 WL4 by EI. So delta is proportional to L ki power 4. So delta there upon delta there 1 mm is proportional to L ki power 4. So 16, that deflection is how much here? One beam is 2 meter long, another is 4 meter long. So it is 4 ki power 4. So what is rubber? This is rubber. 4 ki power 4 into 2 ki power 4. So it is how much? 16. It is 16. This ratio is 16. So delta will be 16. A option. Yes, it is proportional to L ki power 4. Everything other will be cancelled out. Every other thing will be cancelled out. Got it? Got it, friends? Please let me know. Okay, now previous year questions of 2018. These are the previous year questions of civil engineering. Of course, it is equivalent important for the mechanical engineers also. And later on, after just 10 minutes, Dheeraj sir will be coming for the PYQ of mechanical. Okay? Chalo karo. करो भाई. कहाँ? यहाँ. करो. Yes. See, about here, it is BDQ by 12. And about here, about base, what will be the I? It is a parallel axis theorem. Parallel axis BD into distance, that is D by 2 whole square. So it will be BD cube by 12 it is, and it is BD cube by 3. So ratio it is asking BD cube by 12 divided by BD cube by 3. So 1 by 4, A option. A option. Got it, everyone? Got it, friends, or not? Got it. This one. Two forces 9 Newton and 10 Newton are acting on right triangles. 9 degree. So what is the resultant यार? बच्चे को पता है तो यार. बच्चे को पता है. बच्चे को पता है. Sigma R will be under root fx square fy square. So 9 square plus 12 square, that is under root 225, that is 15. C option. That is C option. This is for civil engineering, this pitch. The distance between two adjacent rivets is pitch. Along the principal planes, what is the shear stress? What is the shear stress? What is the shear stress? Shear stress is 0. Okay, I have given this example also, na? Like suppose this is, when principal stresses are maximum, shear stress is 0. When shear stress is maximum, principal stress may or may not be 0. For this case, when shear stress is 0, here the x-axis is 0, but not necessary here. But principal stress, whenever it is maximum or minimum, shear stress will also be 0. It is like when boy is topping the class, first in the class, no girlfriend, 100%. But when girl becomes topper, girls are very hardworking, when girls are topper, so there may or may not be boyfriend. Okay? After 2 or 3 months here. Now, coming here, the bending moment is maximum on a section of a beam where shear force is. The bending moment is maximum on a section. See, I just told you na, shear force is equal to dm by dx. So as you know, dy by dx is equal to 0. Whenever this is 0, the function becomes maxima or minima. The function becomes maxima or minima. Whenever this is 0, the function becomes maxima or minima. Okay. Got it, friends? Got it, friends? Enjoying the session? Okay, okay, okay. Keep sharing. Subscribe the channel, guys, for more such sessions. Okay. The maximum shear stress on a rectangular beam. For rectangle, what is tau max? Tau max is 3 by 2 of tau average. 3 by 2 of tau average. 3 by 2 is 1.5. 3 by 2 is 1.5. Now for circular section, what is tau max? Although it is not asked, but still I am 4 by 3 of tau average. And for triangular section, what is the maximum shear stress? It is again 3 by 2 tau average. Now where this maximum shear stress lies? Can you tell me? For symmetrical bodies, the maximum shear stress is at the center. At center, that is d by 2. At center, that is here. For symmetrical bodies, maximum shear stress lies exactly at the center. So where here lies? It lies here h by 2. H by 2 is not the centroid here. Here tau max lies at the centroid. Not, sorry, I was saying center, sorry, centroid. But for unsymmetrical section, it is not at the centroid. Centroid is 2h by 3. Or from base it is h by 3. It is h by 2 there. Now for I section, where is the shear stress maximum? Tell me. For I section, where is the shear stress maximum? For I section, where is the shear stress maximum? No. It is again symmetrical, na? So all symmetrical sections, what I told? The shear stress is maximum at the centroid. So here the shear stress is like this. Again it is maximum at the centroid. Got it? And this is the shear stress at web. And this is the shear stress at flange. Now what is tau 2 by tau 1? What is tau 2 by tau 1? It is B by B. B is this one and small b is this one. Guys, tau 2 is less area. Therefore stress is more. Tau 1 is in the area of flange, more area, therefore stress is less. So as we are going down, suddenly here area decreases, so stress suddenly increases. Got it? Do this. Do this, a cantilever beam A. So this is a cantilever beam A. What is happening here? Subjected to concentrated load at free end. Okay. Now what happened to other? B and cantilever beam are twice those dimensions. So here it is a B and dimensions are twice. Okay, subject same load PP. Then the deflection of B with respect to A. Delta B with respect to A is to be find out. Delta B, deflection of B with respect to A is to be find out. Now what is deflection of cantilever? PLQ by 3 EI. Load is not changing, length is not changing, only width and depth they have asked. Width and depth, not the length. Width and depth. Okay, so E is not changing, only I. So delta is inversely proportional to 1 by I. So here first of all it is inversely, so A का ऊपर लिखेंगे B into D cube. Okay, B into D cube, and here it will be 2B into 2D cube, right? Okay, this will be 8 16 1 by 16, and of course here if B is having more dimensions, more stronger, of course the deflection will be smaller. So it will be 1 by 16. Okay, so and then the deflection of the free end of the A will be, so how 1 by 16 is how much percent? So if there the deflection is x, here it is x by 16, so how much percentage x by 16 of x into 100, that is 100 by 16, that is 6 point something. Got it? Everyone please let me know. Everyone, सर रेडी हैं आप? ठीक है सर, आप स्टार्ट कर लीजिए ना. हेलो, हाँ आप कितनी देर में, आपका कितनी देर में होगा? बस आप 2 मिनट बाद कर लेना स्टार्ट. मेरा हो गया है. Okay. So guys, now Dheeraj sir will be coming. You can join me in my Telegram group, Civil by Abhinav sir. For more subjects also, for civil and mechanical, we will be coming with the sessions. This is the Dheeraj sir session that will be at 6 p.m. today. The 9-month strategy to complete GATE examination, 6 p.m. today. These are my sessions that you can see. This will be the workshop on Tuesday on app. Okay, so please do register for this workshop. This will not be on YouTube. This will be on app at 7:30 p.m. Okay, so Sunday ka funda is going on and daily dose is going on, so you can see that also. Okay, guys, now Dheeraj sir will be coming and he will be taking you. Please share the session. Okay, now Dheeraj sir will be coming on your screen. You don't have to go anywhere else. In this same screen, Dheeraj sir will be coming and he will be taking forward from here. Okay. Any doubts, you can put that on the comment section. Any doubts if you have? If your 12th is done, then you can do na, on the basis of 12th, not on the basis of diploma. On the basis of 12th you can do if you have done 12th, or you do it from open. But on the basis of diploma, if you have done diploma after 10th class, then not possible. Now the sound is okay. Anubhav, Anwar, please tell me that. Yes. Fine. So guys, now we are starting the session. So as sir have taken the strength of material questions from the civil engineering paper, now I will be taking from RAC and mechanical paper of Isro 2020, which is equally important for both the branches, because you will found that similar questions are being framed. Okay. So now one by one I will be sharing the questions without wasting the time. Sir, I have already told you about the workshop and this session. So this is the very first question in front of you guys. You can see the question. Yes. Baskula, yes. Pejal, Anubhav, Anwar. This is the question. The ratio of maximum shear stress to average shear stress in a beam of rectangular section. You have seen similar question for civil also. So for strength of material, you will find similar question for both the branches. Yes. So Anubhav said 3/2. Very good. Pejal what has said 3/2. Balaji, yes, 3/2. Anwar, yes, guys. So, you know, whenever we are talking about a rectangular cross section,
then whenever we make the shear stress distribution, this type of shear stress distribution comes. This is neutral axis and this is the maximum shear. You know that the maximum shear comes out to be 3 by 2 times of tau average. So they have asked the ratio. The answer is going to be 3 by 2. It is easy question, but it is PYQ. I have not made it for you. This is the second question from SFD BMD. Here they are asking you about the bending moment, and I hope everyone would be able to find out the bending moment maximum at the midspan. So guys, they have given you a UDL for half of the length. So you know, I am giving you a hint that first step will be to find out the support reaction RA and RB. First of all, find out that RA and RC, and after that you will be able to find out the maximum bending moment at B. So guys, just try to solve it. I will give you the time for that. And guys, you guys are doing extremely well by looking at that. If you are going to do the same in all the subject, you are going to get very good ranks. Okay. And you know, these are special vacancies. So original, whenever every year is giving, that vacancies are still yet to come. Okay. So try to solve this. Try to solve this, guys. Okay. Solve this question. Okay, Anubhav Singh have given the answer as 1 kilonewton meter. What about others? What about others? Yes, yes, yes. So guys, first of all, we will go for the support reaction calculation. This UDL is 4 kilonewton per meter acting for 1 meter. So we can assume a load of total 4 kilonewton at the midspan. And when we are talking about the midspan, it is going to be 0.5 meter from left hand side support and 0.5 meter from here. So my dear, now if you want to find out RA and RC, you can apply the shortcut. And when you will be applying the shortcut, RA will be written as what? You will say that it is going to be 4 into 1 point total length. Yes, guys, please tell me now, am I properly audible and visible to all of you? Sorry for the disturbance. Anubhav, Pejal word. So the answer for this is going to be 1. Now we are moving to the next question. Sorry for the disturbance, guys. This is the next question. Next question says the steel machine element at the critical section is subjected to a biaxial state of stress where they have given you two principal stresses, which is 300 and 300. Both are equal in magnitude. Find the von Mises stress. So guys, first of all, this question is from theories of failure. I feel sir already told you, when we are talking about this topic, theories of failure, this is there in the syllabus of machine design for mechanical and strength of material for civil people. Okay. So if you see the von Mises theory, I feel everybody is aware, maximum distortion energy theory is the von Mises theory. And when we are going to talk about that maximum distortion energy theory, or when we are talking about the von Mises theory, I feel everybody is aware that we are going to find out it as sigma 1 ka square plus sigma 2 ka square minus sigma 1 sigma 2 ka square root is going to be the equivalent stress which they are asking, which is said to be von Mises stress value. So guys, when you will be finding out this sigma 1 here is equals to 300, sigma 2 is also equals to 300. You just need to put these value and get the value of SE. Yes, anybody? Please tell me what will be the value. Yes. Guys, now I am properly audible and visible. Please tell me that. I feel a lot of disturbances happen. I don't know why it is happening. I feel some network error is there. Yes, the answer for this question will be D. Yes, the answer for this question will be D. When you will put the value 300 all the times, so you will get 300 ka square plus 300 ka square minus 300 ka square. Answer will be 300. So D is going to be the right answer. Yes, great. Wonderful, guys. So moving to the next question, guys. This is from thin cylinder. And thanks for your patience, guys. Okay, so sorry for the disturbance and thanks for your patience. Next question is, a cylindrical pressure vessel have a diameter of 200 mm. So they have given you the diameter of 200 mm. And they are saying that the thickness is 2 mm. Thickness is 2 mm. And you need to find out the hoop stress and the axial stress. Axial or longitudinal are same here. So you need to find out these two values, and pressure they have mentioned it to be 5 MPa. Let us see how many of you remember the formula for hoop stress or circumferential stress and the axial or longitudinal stress. So I feel everybody is aware that longitudinal stress is 1/2 of the circumferential. So just solve it and let us see how many of you give the right answer. Anubhav, Pajel, please tell me. And do like and share the session, guys. Thanks, guys. Okay. What will be the answer? So giving you the hint, those who forget the formula, hoop stress is PR by T or PD by 2T. And axial stress is simply PR by 2T or PD by 4T. This is from thin pressure vessel. Let us see how many of you give the right answer. Pajel is saying D is the answer, 250 and 125. Okay. Fine. Yes. Here there is a mistake actually. This is 250 and 500 will be there. This option have a mistake. So 250, 125 you are saying. Pajel. What about others? What about others? What about others? So the answer for this is D, 250 and 125. 250 is the hoop stress and 125 is the axial or longitudinal stress. Okay, very good. सर फिर अटक गए तो
बंद कर दो, कोई बात नहीं
यार।
सर। आपका ना ऑडियो नहीं अटका है, वीडियो अटका है।
अच्छा,
हाँ, बीच बीच में ऑडियो आ रही है आपकी, वीडियो अटका है।